Hello everyone. Thank you for joining us today for our webcast on CT technology for lithium ion battery inspection. My name is Udo de Vries and I work as a Growth and Strategy Director at Waygate Technologies, Industrial Radiography, and I'm the lithium ion battery inspection expert in our company. Before we begin, we want to cover a couple of housekeeping items. At the bottom of your screen, there are multiple application engagement tools that you can use. All the engagement tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to the full screen by clicking on the arrows in the top right corner. If you have any questions during the webcast, you can submit them through the Q&A engagement tool. We will try to answer these during the webcast, but if a fuller answer is needed or we run out of time, it will be answered later via email. Please know we do capture all questions and hope to find the satisfying answers for you. A copy of today's slide deck and additional help materials are available in the resource list. We will encourage you to download any resources or links that you may find useful. In today's session, we will cover the following topics. First, a quick introduction of who we are and about our technology. Then we go into the typical lithium-ion battery inspection applications that we see across the board in the industry. Then we look into typical inspection solutions that are enabled by CT technology. Last but not least, we rounded up with a look into our portfolio and how we can help you with our solutions to fulfill your inspection needs. First, a couple of words on ourselves. Waygate Technologies Industrial Radiography is the acknowledged world market leader in CT applications for non-destructive testing and metrology. The foundation of our success is the long-standing customer application know-how in combination with our capability to transfer the needs of our customers into world-class engineered solutions. Our key differentiator is the productivity and image quality of our products, and we leverage automation to provide the most fitting solution for the R&D or production tasks required. We can leverage our radiography store, which is our own tubes, detectors, and tailor-made software to create the most fitting and best working solutions for you wherever you need it. The key to success of your CT system are really the key components that are used in the system. We have our own X-ray tubes, we manufacture our own high voltage generators and have access to proprietary detector technology, which enables us to provide the best solution to you. Our success in the market is reflected by more than 4,000 customer installations for mini, micro, and nanofocus systems globally. Waygate Technologies' lithium-ion battery inspection know-how is a direct result of the long-standing experience in inspecting 2D and CT electronics. As our inspection tasks and consumer electronics expanded over the years, we became more aware of the special needs for inspecting lithium-ion batteries. And now with the application of batteries more and more in public and personal transport, the needs are rising, and also the inspection task is much more multifold than it was in the beginning. We will look on the next page the environment, especially in the EV space. Across the battery environment, we work with all major stakeholders. We work with the battery cell OEMs, we work with the automotive OEMs, both for passenger cars, but also for trucks. We see packagers and EV subsystem suppliers who are taking cells and building them into sub-assemblies, and we work with a whole range of academia, university, who always try and strive to build the most capable batteries for the future. All of these four stakeholder groups are using CT systems, but they have different applications and are looking into different elements, as you may imagine. And in the later slides, we will have a look at what are the most compelling and most interesting inspection tasks they are looking in. CT technology is applied for inspecting all kinds of major battery designs that are currently in use across the industries. CT is used for cylindrical cell inspections, for pouch cells, all kinds of sizes, and for more and more designs of prismatic cells. X-ray CT is applied to inspect battery cells integrated into modules, and modules integrated into battery packs for EVs. Manufacturing defects, which are mostly looked after, are electrode geometry or overhang, as it's called mostly in the industry. We look for foreign body material on electrodes, but also in the cells itself, coming out of various reasons. We look for gas bubbles and electrolyte filling, the homogeneity of the active electrode material inspected, welding and welding fragments or defects are inspected, like porosities. Dimensional accuracy of the housing is checked, and also in the modules, the resin filling and generally assembly. In the film which follows now, we will have a quick look at typical defects and how they look like in the most prominent way in CT technology. We will now look at some details of CT scans of the different kinds of battery cells. What you see here is a pouch cell, a classical stack in a pouch. You see the tap, and you see the whole stack with electrodes, anodes, cathodes, and separator from the outside. On the next one, we go into some of the details, which I would like to highlight to you. This is the corner of the pouch cell. It's taken a 5-micron voxel resolution, and you can see nicely the major details which you want to see. Obviously, you see the pouch, the outline. You can detect the separators between anode and cathode. You can see the difference between anode and cathode from this view. And you can also get an idea already of the stacking and maybe of bendings that you won't want to see. Here's the same cell, but in the side view. You see nicely the stack of anode, cathode, the separators, the pouch around again. But what we are looking here is really the stack homogeneity, and you can already see some defects which point out at not a homogeneous stacking, but also have some cathode material missing in the middle of the stack. This here is a slice of the same battery at a different position. the same 5-micron voxel resolution. But the point here which we want to highlight is that you can nicely see with CT also voiding in the cathodes, which indicates its inhomogeneous material distribution and will result in early failure or malfunction of the cell. Based on the very fine resolution of the CT scans, you can use the data also to do 3D renderings of the cell to highlight other sources of malfunction of the cells. In this particular case, we see very impure cutting of the anodes, which results in sharp ends, which can harm the pouch, or, on the other hand, result in flaking of the anode material, which can lead to other malfunctions. Another very obvious failure can be seen here. We see the defective cathode edge in the middle. Obviously, it's missing. And also inhomogeneous material in the cathode. As you can see, very nicely to be highlighted with CT. Moving over to cylindrical cells, the failures we looked at before can also be seen here. You see different slices here of cylindrical cells, the whole cell, the upper head of the cell, and the layered view through the cell, which gives you already an indication of what we can look after. In this view of the cylindrical cells, we have highlighted some inaccuracies and defects that are quite typical, which is voids in material on the upper right picture, inhomogeneous winding or delaminations in the roll, and of course, again, overhang, as you can see in the lower end pictures. All kinds of defects that we've seen before on pouch cells and cylindrical cells can obviously also be found in prismatic cells. Prismatic cells have the additional complexity that the jelly roll is put into a can, which has separate connectors, but also has a gas seal, and there are more parts used in a prismatic cell, which lead to more failure modes. To highlight these failures, we've taken a couple of images which are typical for a prismatic cell. In the upper left corner, you see again the cell stack with the connectors coming out and the combination of connectors, or the welding of the connectors on the top. Upper right corner is a typical etch, again the stack, but with more connector material and also the seal already in view. Lower left is the jelly roll. This is a very nice one, very homogeneous. And the lower right one is another view which shows the kind of folded connectors coming out of the stack of anodes and cathodes. As we've seen on the previous slides, a lot of kind of different failures can be seen in the cells itself, and with enough time in R&D, you can highlight even the tiniest detail. When you transfer this kind of task into a highly effective and productive manufacturing environment, you want also to find typical manufacturing failures, but you want to find them in seconds and minutes. That's why we see more and more the demand for automated defect recognition software, which helps customers to define defects fast, immediately in production, which enables them to really reduce the scrap rate of their production. You see a typical workflow here, how this works, and it's really aimed at reducing the inspection time and enhance the operation simplification. In the next film, you see how this kind of ADR software will be applied in our latest product, the Speedscan HD. As you've seen before, Speedscan HD is the tool for battery inspection in the line with high accurate CT, which allows you to inspect multiple failures at the same time. The system is designed to inspect prismatic and pouch cells in the fastest form ever, and with an accuracy you haven't seen before, which allows many more applications than just in a classical 2D system. We are right now building the first prototype of the system, which will be ready by the end of May, and are aiming for the first customer installations by end of the year. Obviously, there are more automation solutions available for your battery inspection solution needed, meaning we have assistant robot systems for at-line inspection, and we have also robot systems already enhancing CT inspection for modules released. So ask us when you have something special on your mind. For inspecting battery packs, you need a high-energy CT system. We are right now building the first one in Cincinnati, Ohio, and the system will be hosted in a bunker in a separate building. It has a dual-tube system with 9 mega-electron volts, which allows for the penetration of the most dense parts, and you can bring in parts which are 2 meter by 2 meter and up to a weight of 1,000 kilos, meaning a battery pack would be a nice part to inspect here from the assembly, but also from the integrity of the components point of view. The previous slide showed the rendering of the high energy system, and here you see the full prototype already being built before integration into the bunker in Cincinnati. Looks like a normal system, but when you look on the upper right corner, you see a human on the system, which gives you an idea of the dimensions, and obviously the bunker to host it. What will be typical for high energy inspection is that we offer this kind of inspection of battery packs as a service. And this is the point where I also want to introduce to you another product that we have, which means we can inspect batteries on call globally. We have a global network of application centers on all major industrial zones globally, which allows us to help address your inspection tasks in the right time zone at the right time, with the same quality and the same capable experts that we have around the globe. We have centers in Japan, Korea, China, India, in Europe, and 2 major centers in the US for single part inspection, but also series inspection. So if you don't have your own system, bring us your cell, bring us your module, bring us your pack. We will inspect it for you. To summarize our joint journey through the different inspection tasks and possibilities for lithium-ion battery cells, module, and packs, you see here an overview of the portfolio that we have in place to support your R&D, production support, but also inline production of battery cells on the different continents, but also, as I mentioned, as service available. We have the most comprehensive portfolio in the industry, which is available at your service to solve your issues that you have in the space. But also, I would like to encourage you to reach out to us if you have something new and up and coming, as we always want to learn and improve, become better, and to find better solutions to inspect your batteries. I thank you and look very much forward to your questions now. Hello, everyone. This is Udo de Vries. Thank you very much for joining our webinar today on CT lithium ion battery inspection, and we are now about to start the Q&A session. As a reminder, down below on your screen you have 4 tabs. One of them is Q&A. There you can put in your questions, and we will be now starting to answer the first batch that we have received so far. So please answer your put your questions in, because now's the time to answer. Otherwise, I can also do it later by email. Welcome to answer your questions. Gina is also on the line, will ask me the questions, and I will try to give the answer, supported by Nayara, who's also on the line. Should we go ahead?
Sure. So Udo, our first question is, can you also scan battery modules? If yes, what kind of size can you inspect?
Thanks, Gina. So obviously, the answer is yes. So we've scanned modules of different sizes. Modules come pulled together by pouch cells or by prismatic cells. Let's say predominantly the size is about up to 700 millimeters of height, the width up to 200 millimeters, and the depth up to 150 millimeters. And the weight is from 10 to 40 kilograms. So these are already quite dense and compact parts, which are being inspected by us, or where we have helped customers to find the optimum inspection solution for.
Awesome. We also have a follow-up on that question. So what kind of resolution can you achieve on modules of this size?
That's a very good question. So obviously, the resolution is always dependent on what is the optimum system needed to fulfill the inspection task, but also what's the time available for the inspection task. But we usually would go for a resolution of 70 to 130 microns. Obviously, the other point which always comes in connection to this question is, so what's the scanning time? And obviously, when you have a big module and you want to scan the whole module, the scanning time can be up to 6 hours, but it can be also as low as 10 minutes when you know exactly which part of the module you want to have inspected and want to check on a certain parameter to make sure that your parts are in order.
Okay, in which customer locations is CT applied for batteries?
That's a very good question. What we find is that it goes from cradle to grave, you would say. So it starts really at the component level, that cell architecture departments in battery OEM, but also at car OEM, are using CT for inspecting electrodes, anodes, and cathodes, sometimes even down to the granularity of the coating and manufacturing samples of the coating. Then it goes over to the R&D departments focusing on the cell architecture, who are pulling together new prototype cells, looking at the certain elements when the first beta series is produced. And later on, it moves over to the quality departments in the production lines, who are either inspecting in-line or who are inspecting at the line certain kind of parameters they want to inspect. And obviously, it also goes over to after service, when cells are coming back from the field, need to be inspected for certain parameters, experiences, issues which might occur when cells are used. So it goes really from the invention of a new cell or a new cell type for a certain job till verifying in field how the performance of the cells is, and obviously then comes together with different tasks asked from us to inspect these.
Okay. Have you been able to detect any types of degradation in batteries after cycling?
There are indicators that you can find this kind of degradation. It's indirect methods coming from different, let's say, look of the anodes and cathodes, and sometimes also changes when you compare a brand new cell in comparison to a cycled cell? So the answer is yes, but obviously that needs to be done for each cell, meaning for each cell type to have a look at how this works out for the specific model. What is sometimes a bit tricky is the lithium part because it's not easy to detect, but to my previous answer, it is possible indirectly. Next one.
Okay. What type of detector is used in the 9 MeV system?
We have, not that I say anything wrong, we have 2 detectors, if I remember right. One detector is a line detector and the other one is a standard digital flat panel detector. But I can look it up and post the answer later on again in order to make sure that I have not talked nonsense here. Let me see, I just looked it up. Yeah, it's a line detector and a digital flat panel detector. Yeah. Next one.
Will this 9 MeV system be available as a product or only for services?
It will be available both. So we will offer inspection services with the 9 MeV system because we see a high demand that customers want to send parts and we inspect them in our facilities. But we are also offering the system right now already to customers who want their own installation at their sites. So both product and as a service.
Okay. Is it possible to scan only a small region of interest of the battery, and how does this work?
Yes, it is possible to scan only a small portion of the battery. Obviously, a small region of interest can always be scanned, as well as the whole batteries can be scanned. So we can also look into only corners, and one of the most prominent inspection tasks is overhang, and only a corner of the battery is scanned. We can also look at the taps. We can also look into certain central areas in the batteries. So if you define which part of the battery you want to have inspected, you can describe it to us, and then we can try it out and provide you with the results. Next one.
Is this 9 MeV system operational now?
That's a good question. The 9 MeV system is developed and was pre-assembled. It's now being finally assembled in Cincinnati, Ohio in the US. So the integration of the parts into the bunker is happening as we speak, and we will see the first scans sometime in June this year.
Okay. When does the exam start with the new LINAC, and how much does an exam cost?
To my previous question, we will start official service in the second half of this year. And the exam cost depends really on the inspection task at hand. So I would recommend, when you have an idea of what you want to like to scan, just send us just a small email and say, look, this is the part, this is what I need. And then we can really look into how long it will take, what the pre-arrangement needs to be done, because it will determine in the end the pricing. Next one.
Can you please talk about radiographic inspection of polymers to detect different materials and different densities between layers?
That is a very good question, and I would like to take this offline, because one of our very experienced application engineers has looked into that, and I would like to consult him. So I will put this question on unanswered, and then we'll consult with him and send you an answer on this question afterwards, because I'm not knowledgeable enough to give you the proper answer straight away. Next one.
Okay. You mentioned ADR. Are there predefined defect types pre-programmed? Is there machine learning, or must the operator train the system in the field?
So right now we offer ADR with predefined defect types, and these predefined defect types are tested out. The operator will have also the chance to activate a machine learning mode while operating these predefined defect types to refine the inspection task. So there's also, for these predefined defection identification modes, is also an additional learning mode that the identification of this failure becomes more accurate and more reliable. So it's both. However, a complete new inspection application will always take more time than taking, for instance, an overhanged inspection predefined mode that we have already created. Next one.
Does a 9 MeV system cause materials to become radioactive?
No. The answer is no, because this is well below the threshold of activating material. And obviously, we inspect a lot of parts for customers who want to use their parts in all kinds of application where this is definitely not acceptable. So the answer is no. Next one.
What would be a resolution of 9 MeV system during battery inspection, for example, in comparison to the L450 system?
Okay, the resolution for battery inspection of a module or a battery pack would be lower than for the L450 system, as there's a greater distance of the source and detector to the part itself. The exact value we can only determine after we've started the testing with the new machine. We expect it somewhere in the range of 100 microns, but I cannot give you the final answer right now. It will really come after we've tested it out. Next one.
What kind of failures can CT detect for lithium ion batteries?
CT can detect a whole range of failures, and I hope some of that was already mentioned. The predominantly ones that we can detect are really all kinds of geometric failures, foreign body material in the cells, flaking, breaking, electrodes, connectors not connected, electrolyte filling, resin filling, the whole range of things which can be compared with the original CAD file to the part itself. So it's a whole range, and I refer back to the presentation, which we will make offline available for you, where we have listed these failures, but also when you see something new, feel free to reach out. Happy to look into new failure modes as well. Next one.
I heard Waygate Technologies has various customer solution centers. Can you tell me where these are located?
Yes, we operate customer solution centers around the globe. Around our headquarters in Europe, we have 3 or 4, three major ones in Germany, one in France, one in UK. Then we have 2 major sites in the US, one in Cincinnati and one in San Jose. And in Asia, we have a strong footprint led by China with 2 centers, one in Shanghai and in Dongguan, another one where we do a lot of battery work in South Korea in Seoul, and we have a small center in Japan and a small center in India.
When calculating the radiographic exposure, which beam energy is chosen and which is the main criterion considered?
That's a good one. And I also would like to take this offline, because I would bring this again, to the earlier question with the polymers, also to our application engineer, that we can give a precise answer on this. So please put it in the open section, and then we do it afterwards.
Perfect. Can you find pinholes in paper in capacitors?
Good question, Randy. I would say the answer is yes. And I think we've done this already for capacitors. And I would like to try to find an example for this. So also moves us to the open question, because if we have an example, it would be easier to show you this in an email. Next question, please.
With what resolution can you detect poor electrolyte filling in a large pouch cell? Does this require CT scan or just a 2D X-ray scan?
We've tried both 2D X-ray as well as CT, and we've seen the better results with CT. The resolution, well, and the answer for it was with CT, you can see the distribution of the electrolyte in 3D, which also sometimes you have dry spots in certain areas, which you can highlight by this while slicing through the battery. The resolution, if I remember right, was in the range of up to 20 microns. And there were various, let's say, electrolyte filling levels that we could observe, or also areas which are not or no longer covered by electrolyte. So yes, this is possible. Again, large pouch cell, if you have a large pouch cell which is, let's say, 300 times 10, or 300 times 100 centimeters or millimeters, or 400 times 150 millimeters, there you can do it, but you can also do it with smaller ones. So it depends a bit on what kind of filling you look for, but generally this is possible with the ranges I've just given. Next one, please. Or I see that might be the last one. Okay. So if you still have a question now, I'm answering my last question. If there's still more, please bring them in or send me an email. But afterwards, yeah, just go, Gina.
Okay. Are there test scans of new battery cells, battery architectures, and components possible? If yes, where can I do this?
Okay, that's an excellent question. Obviously, there are test scans possible, and I can only encourage everyone who's on the call to approach us. So we do demonstrations all the time for customers to show our systems. So please feel free to send us your parts or contact us to discuss your inspection tasks at hand. And you can do this at all locations I've just mentioned earlier, in North America, in Europe, in Asia. And we have people who are trained on inspecting particularly lithium ion batteries, components of these and modules. And so also we are always interested to learn about new inspection tasks and new failure modes. So first scan is always possible for free. So feel free to reach out, and then we can look into your task and determine jointly what needs to be done and what is of interest for you. Next one.
Have you applied this technology to components for NASA?
We have worked with NASA. We have installations with NASA. I'm not particularly sure whether we've tested NASA batteries. Tentatively, I would say yes, we have, because I remember something, but I need to look it up whether there was something done. On the other hand, yeah, exactly. I don't know particularly, really. So that was the last question I had. Any other questions which are still out there? No? Then if still something comes up afterwards on your mind, feel free to send this out to my email, which is part of this package. Thank you very much for attending this webinar. Very liked the questions, very good questions and detailed questions. And stay tuned. We will obviously, once the high energy CT is up and running, we will publish more on this we will talk more about the Speedscan HD product, and also publish more details on our own trials in lithium-ion battery and new solutions coming in inspecting lithium-ion batteries in the future. Thanks again, and hope to hear from you soon. Bye-bye.